Alright, so I'm gonna section off this area. I realized I might run out of some column space, so I just moved these two comments above. And the first thing I realize is when we're calculating the tile x and the tile y coordinate, we are going to need a math.floor here on the result of the division. For example, let's say that your tiles are 64 by 64 pixels in dimension, right, on the x and the y. So if you're sampling a pixel on the viewport and you are at 32, 32, right? You're not at if you're at 32, 32, you're still within that 64 by 64 tile region. So you're still at the first tile, right? Because let's say 64, or actually 32 divided by something bigger than 32 is 0. Well, I guess that's 0.5, right? Yeah, 0.5, right? And then we floor that and we get 0, right? So the first tile at the very corner here is going to be, the first tile at the very corner here in our viewport is going to be 0, 0, right? So if we're right in the middle here, and that's like 32, 32, and then over here is 64, we can just use division to calculate, which tile you're inside of. But we're not accounting for the translation of the sampling viewport, and we're not accounting for translation of the destination viewport. So we need to think about, how does the translation of both of these change what the output is? And the first thought is, okay, what happens if I, instead of starting here, I start over here? That would just mean you would just add, you would just have to add 1 to the result here of what tile you're in. That's all you would have to do. And you could just plop it on here at the end. And that's if, so we have to think about this. So the viewport selector would actually be moved. So here's 0, 0 for our viewport selector origin, and if it was like moved over to 1, 0. So we're actually going to add the origin. All you have to do is add the origin of this viewport number 1 selector to account for that translation. And am I missing anything? Yeah, so let's just do that. So at the end here, we just need to add viewport 1 and this x0 and x1 here. Or you could add these. We got a little bit of indirection here. I guess we might as well use the SX0 and SX1, or not SX0, but the SX0, which is the origin X value, and then the Y0, which is the origin Y value for that rectangle. And so that should account for if this viewport moves from, here, and then if it moves down or over or whatever. That's going to account for the that's going to account for the translation. And now we have to think about, okay, well, what if this viewport moves? Like, how is that going to affect the formula? Like, are we just gonna, so you just gotta like add or subtract this value, or is there something more here that I might be missing? And my thought is, okay, if we're over here, but the viewport, if the viewport actually starts here, and the dx and okay. So with my mapping, if this is everything that's supposed to be on screen, then when this viewport moves around on the if this is everything that's supposed to be on screen, like this is what our what we're sampling, if this moves around on the canvas, this viewport, it just moves around, but it doesn't change shape or anything, what is seen inside of it should not change at all. So what we need to do is this point here, this coordinate, needs to be turned into a local coordinate. So if this viewport is currently like at coordinate 32, 32 on the canvas, we need to subtract 32 from our calculations. Otherwise, moving around the viewport is going to change what the contents of the viewport have inside of them, and that's not the effect that I want. I want you to be able to put this viewport anywhere on the screen, and it always has the same contents, right? And if you like shrink and stretch the viewport, it still has the same contents. Shrinking and stretching the viewport should just change how much zoomed in or zoomed out you are, but it always has the same contents, right? Like if we make this viewport 8 by 8 instead 8 by 8 pixels instead of the 4 by 4 that it is right now, it should still always contain this content. But if we give it more pixels, right, then we're making it bigger, then effectively it is zooming into this, right, because we're going to see more detail. So making this viewport bigger will effectively zoom into this data. Okay, so with that thought, we're going to need to subtract vp0.x0 and vp0.y0 from these dx coordinates. So we could also, do we have a variable for local coordinates? We have local for the current tile, but not local in terms of the destination. So I'm gonna I guess that's kind of why. Whatever. Let's just inline it. That's another thing. Making like long one-liner formulas. One advantage to that is you don't have to come up with a new variable name for something, right? We can just do the math right here. So we're gonna take the and so dest dx0 dx1 x0. Okay, so these guys. Okay, so subtract. I'm going to subtract dx0 there. And then destination y0, right? So we're going to subtract the, wherever this corner is on the canvas, we're going to subtract that so that dx and dy, we're basically transforming dx and dy into a local coordinate, right? And let's make sure that that's what we're doing. So dx, and if we look at this, okay, so this is the rectangle bounds of the destination viewport. So yes, we're transforming the dx, dy coordinate into local coordinates. Now that could be kind of useful to use elsewhere. So maybe I don't want to inline this. So I'm just going to say var dst local, maybe. Or we could do this. We could do LDX for local DX, for local destination X, equals DX minus DX0. And then LDX local chord dest X, right? Just a little comment there to let us know what that means. And then we have LDX, so we also need LDY. So the non-local coordinate, right? Just the coordinate of in our selection area for the destination viewport, minus the top left corner to make the coordinate local. Okay, and then LDX, LDY, and then we can just put it in here, right? And then we could remove the parentheses if we wanted to. I might do that later. Okay, LDX, LDY. I'll make a little note here. Convert dx, comma dy to local chords, and then LDX, LDY. So that we kind of know what we're doing there. And this comment's important, so we know that these are supposed to be local chords, and then if we look at the math, and we're like, this isn't local chords, something's wrong with that formula, what the hell was that person thinking, you know? So this will just help us double check, right? Because what's more likely, that I get this comment wrong or that I get this math wrong? And I'm going to tell you what, it's more likely that I'm going to write the math wrong than I am going to write the comment wrong. And that's why I think comments are an important redundancy in the code, because, you know, people say, well, what if the comment doesn't match the code, as some type of justification for not having comments. But I'll tell you, most of the time when I find bugs in my code, it's because the comment was correct and the code was incorrect. So, so yes, I am pro writing comments all over the place, and I will not apologize. Okay, so we've converted it to a local coordinate, and then we're going to take that local coordinate, and this is the size of an individual tile as it appears on the destination viewport. Okay, so we have accounted for this. We've accounted for this viewport moving around, and then after we've calculated what tile we're on, we also want to account for if this has been translated, and if the selector can't move backwards, negative. I mean, technically it could, but I don't think we want to solve for that. It's always going to move forward. So if it moves to 1, 1, the first tile would start here instead of here, so all we got to do is add. So, and we have the addition here, and it should work out that if you were to somehow move the origin negative, the math here should still work for that. So the results of this formula should kind of match this formula here. So this formula should just kind of be like an expanded version. So if we look at this, this probably looks like our local LDX, LDY. Yeah, because DX, DX0. Yep, and that's the top left corner of our destination rectangle. So that is local X, local Y, divided by, looks like the, how wide the destination rectangle is. So do we have, oh, we have some scaling here. Why do we have scaling? Huh. So I may have missed something. So, and that's the side length. Okay, so yeah, this is the side length of this destination viewport. And if we look here, this is the side length of the destination viewport, so we calculate that. And then we also have the offset of of the source. So we've definitely included that. So we have the offset of the source right here. But I'm missing something because I already know that this formula is correct. So I'm wondering, why am I scaling by I'm scaling by the source viewport size. Why am I doing that? Because initially I solved this up here, so it must be important, but why is that needed? Why do I need to scale? Yeah, that doesn't... Because we already accounted for... Huh. That's interesting. So I gotta think about that. Why is that scale factor in there? I kind of... Let's make sure it doesn't, like... What the hell? Why do I need to scale that? This is the problem when I solve things completely algebraically. I don't quite... You solve it, you move around the variables, but then maybe you don't understand what the transformations mean. Because honestly, I have no clue why I would need to scale the value. Okay, so we make it into a local coordinate on the destination viewport. And then we divide by the tile size. Oh wait, hold on. This is not the tile size on... Oh, okay, I see. So... No... Okay, making it local. Oh, okay, so I see. It's, this formula is a little bit different. So I'm getting I'm converting percentages. Yeah, that's what I remember. And that's why there's a scale factor here. Because I'm gonna make dx into a local coordinate, and then I'm putting it all over the length of the destination viewport. So that means I'm converting... This right here is a percentage, so I've converted dx into a local coordinate, but the local coordinate is a percentage from 0 to 1, right, representing 0% to 100%. And then I'm going to scale it by the length of the source sampling viewport, so sx1 minus sx0, and that will have that'll get me the local coordinate of the source viewport, the viewport that's sampling the tile map data, but it won't account for if that viewport has been translated anymore. So then we got to convert it back into like a global coordinate, and that's why there's that sx0 there. So that's what this formula is all about. So that's why I have that scaling there. And this formula here is not doing it that way, right? It's not taking the time to solve it by converting it back and forth into a percentage. But this tx and ty this formula should resolve to the same thing as Sx and Sy, I'm pretty sure. But let's go through the logic of this. So I already know that this logic is correct because I already ran it and we've been seeing the results of it. But let's make sure that that this is correct. So let's go through the logic again. Converting the destination viewport pixel to a local coordinate, we kind of already know that's correct because we see it here as well. And after we've converted it to a local coordinate, we're going to divide by the... oh, interesting. It's almost like we're taking out a step. Because instead of dividing by the destination viewport width, we're dividing by the source viewport width. Yeah, so it's almost like these two ratios, we kind of like... okay. So, and does that make sense though? Because we got the local coordinate here. Oh no, this is not the viewport width. This is the tile size, right? And the tile size is this. What we could do is we could kind of expand this formula a bit. We can use substitution and kind of expand this and see if there's any similarities after we've expanded it, right? So I'm going to make a comment here. I'm just going to be like, use substitution to expand formula above. So I'm just going to use substitution, and I'm going to take this guy, and I'm going to put it back in here. And because I'm just using this to kind of check my work, I don't even need this. I can just say floor, or floor, you know. And we'll look for where we calculate this. Okay, right here. So we're gonna drag that out and put that here. Okay. And then these guys and these guys as well, right? Oh god, that's a lot of did we have a variable for the viewport width in here as well? Yes, we did. Because VP0 width, what we could do is I'm going to move this down. I'm going to move it past here because I noticed that I'm kind of like because this is these guys right here. Yeah. Okay, so what I can do is I'm just going to do this just to make sure. Check. And then var VP0 width. Actually, we can do this. We're gonna and that should be VP0.x1, so dx1, and then okay, so this guy up here. So I'm noticing I've got that +1. Okay, so this guy right up here, y1. Okay. Okay, and this guy right up here. Okay, and I'm just gonna assert that, you know, these variables are the same. Obviously, they should be, because I've just transcribed them, but it's just like I'm paranoid. I want to make sure that as I'm switching things around, I didn't accidentally make a mistake. So, we'll just say that if this is not equal to the check version, throw WTF number 1, right? Because it doesn't matter what the error message is, just as long as I can have it show up in the console and locate it. So WTF01 and WTF02. And these are the widths of the viewport 0. Okay. Lengths of sides of viewport 0. Okay, so now that we have that, and the reason I just did that was because this takes up a lot of space, column space, these equations. So I wanted something a little bit more terse so that as I'm substituting in the equation below, I have something a little bit more compact, a more compact expression. So we can look here, and it's down there is where we're substituting. So we're just going to take this, copy that, and it was these guys, right? Yep. So down here, we're just going to paste that using substitution. And now we have nx and ny. And let's go see where that is defined. So nx, ny. So same thing. I also want to make this a little bit more terse because this also does take up a lot of space. And it looks like this is the same deal as before, but it's the destination viewport. So I'm going to take all this code, and guess it makes sense to go from 0 to 1. So we will do the same thing again. I'm going to paste that there. And x and y. Okay. And rec vp1 0 width. Okay. And we never even used that anywhere, did we? Var vp1 width and var vp1 height. See if we are... Oh, hold on. Oh, I see, because we're these two are have the same meaning. Well, since these variables are synonymous with each other. Do we want to... okay, we'll just leave that as it is. I just do a little thing here, ns for number of sections. It might be easier to think about it though if we nx and ny. Okay, well, even though that is what it means, we still need to make this terser. So I'm going to do the same thing as before. So I'm going to say this is nx and ny check. And then we're going to make it terser. So we have the values up here. I'm going to take this, copy it, paste it. And now we will go up here and find that x1 is sx1. sx1, yep, because that's vp1. So sx1, and then, oops, sorry, sx1 right over here. Down, oops, sorry, can't see that. sx1, I'll put some breakpoints here. And then x0. Okay, so sx0. Okay, and then it would be the same thing with the y's, but for completeness sake, I'm going to still kind of like reference the code as I'm pasting it. Okay, and then the last one is this y0. Okay, so that is, yeah, okay. Okay, so now if we look at that, we got our x's on the top, y's on the bottoms, the 1s and the 0s are lined up, so that should be correct. And then we'll just do a little thing where we check to make sure that, you know, when we transcribed that we didn't make any mistake, right? And obviously this is, you know, some wasted calculations, but better to, you know, make absolutely sure everything is correct. Right? Slower running correct code is better than faster running incorrect code. So we'll just take the nx and the ny from here using column selection, and then we can just paste it there and paste it there. So now we're kind of like double checking stuff. So it's kind of like we're running unit tests like every second of the game in a way. Which is unnecessary, but like I said, better to have correct slow code than incorrect fast code. Okay, so now that we've kind of expanded that, we can take all this. I'm going to kind of condense it a bit so that I can paste it where it needs to be pasted. And nx and ny. And nx and ny are right here in the formula, so now we're going to take that and paste it there. And so the reason for pasting all that was I wanted to see if, when I expand this formula, if it starts to look like the formula over here. And it doesn't. There's a division and a multiplication here. It's not quite the same. So it looks like the destination and the source widths are being divided by each other, so we're kind of like getting a ratio. And we're also, okay, we're taking the local coordinate, and then we're dividing by a ratio, and then we're adding an offset. So I think if we, I can't be certain, but I'm going to guess that if we flipped this ratio, like if we take this and we put it on the other side of the division sign, then we would have to multiply instead of divide, and that would give us a multiplication with the division, which would definitely give us, oh no, this is division and a multiplication, hold on. Okay, but this seems pretty sensible, this formula, and I'm fairly certain from, you know, breaking it apart and from expanding it, it definitely looks, it seems to check out. It seems to do the same thing as this formula, just things have been kind of shifted around in a different order. No multiplication. So actually I'm going to take this formula for a second, because I'm curious, and we're trying to solve the math today, so I'm not going to worry too much about it. But if we take this formula, can we get this formula here to look like, can we get the SX/SY formula to look like this, right? So we already got this part. This is the same, oh, okay, that's interesting. So it looks kind of like this formula was accounting for off by 1 errors. So I noticed some strange artifacts in my rendering code. So I'm thinking this formula might be off by 1. And if we can shift things around until it looks exactly like this, but for some reason is missing these +1s, I would say we have an off by 1 error. So let's say we have like but it's being added to both sides before it's divided. So does that actually change the fraction? So is quick test to think about that is 32 divided by 16, right? We get 2. And if we added 1 to each side, 33 divided by 17. I'm guessing that's not 2. I mean, that obviously looks like it's not 2, right? And we can check our sanity really quick with a calculator. So I'm going to just pop that into Google. And we're not going to get a 2, right? We get something very close to 2, but not quite 2. And with that, right, that would be a very subtle error. So I'm going to guess that my SX, SY from the previous tutorial, I'm going to guess that formula is wrong. Right, because I said that TX, TY, and SX, SY, these values should be the same because I was just solving the problem again. But yeah, let's try to shift things around and see if we can get these two formulas equal to each other. So so divided by that, is this in the other order? Divided by that. Huh. Okay, well, one thing is, I'm gonna make some room here. So most likely I have parentheses where they're not really needed, because I'm taking this value, then I'm dividing, and then I'm multiplying, but I could switch this around. As long as I keep this here, I could multiply and then divide, and if I did that, no, that's still kind of, no, because that's that. It's like the same damn thing, except that is worrisome. Like, how could this... I feel like... Huh. Okay, so this is kind of like shifted around. Interesting. Okay. This is not... It almost looks like the same damn formula, but... plus SX. Okay, I'm gonna try to line this up a bit more, because I think maybe I'm not seeing something. Okay, so these are the same guy up here. And these are the same, except for whatever reason there's, I'm adding 1 to it. But the order is different here, because I gotta remove some parentheses, is what I gotta do. I'm gonna take all this and see if we can get rid of some parentheses. So we're doing this first, and then... Huh. I need to be better at my algebra skills. Okay, so I think that my hunch is that the SXSY formula is like off by a very slight amount because it doesn't have these plus ones, and that otherwise these formulas are identical. Like if I remove the plus ones from the formula on the top, then I'm pretty sure the formula on the top and the formula on the bottom would equate to the same thing. But it's just a hunch, and my algebra skills aren't quite good enough to quite verify that. But that's the hunch I have. So we're using substitution, and I don't know. Do I really need to? I guess I can save this. Making sure everything lines up correctly. So there's the division, multiplication, and kind of like line everything up to see. Since this isn't actual code we're going to execute, I could probably add square brackets in certain areas to kind of help me visually parse this information. And add some square brackets here, and some square brackets here as well. That's just, I'm using the square brackets just like the parentheses, yeah. But I'm just using them to kind of help me see what's going on here. So it's all this plus all that plus as well, and you can add more space, and I guess I could try to line that up a little bit, but it's not really connected, is it? Okay. So that's this times this. Yeah, so I have, or you could do, yeah, so I don't, yeah, because we're just grouping, the top one groups this, but the bottom groups this, and then depending on the grouping, we've changed if we multiply or divide or not. So can I algebraically kind of like prove this with some solid numbers? Like if we had 4 divided by, and then 1/2, or instead of doing that, if we grouped it differently, if we had 4 divided by 1, and then we times it by 2, is that the same thing? So 4 divided by 1/2 is kind of like multiplying by 0.5, right? So yeah, I think those might actually check out to be the same thing. I'm going to do a little check. Let's full screen this. Okay, so we get 8. No, that can't be the same. Really? Yeah? Okay, yeah. What is this? Yeah? Four divided by 1 times 2. Okay, yeah, so maybe, let's try, yeah, I got 8 for both of those, right? So maybe I can just, I don't know why the hell the calculator is so, oh, yeah, because I'm using a shit browser right now. I gotta stop recording because I probably went over my time limit.